Hello student, I am Pallesir from Pallesir Science Academy Udugir. Today we will see electricity. Electricity has an important place in a modern society. It is the form of energy and it is used in homes, industries, hospitals, offices, etc. And we totally depend on electricity for our different activities, such as electric current is used in a computer, and also the fan, television, refrigerator all depend on the electricity. So in this chapter we will see what constitutes electric current, how does electric current flows through the circuit, and what is important to control the current and how does it regulate in an electric circuit, and also we will study about the heating effect of electric current. So first we will see electric current. What is the electric current? Generally we know that the flow of charges through the conductor is called as electric current. The flow of electric charges through the conductor is called as electric current, and also as we know that the amount of charges passing through the particular cross sectional area in unit time, that is called as electric current. Here we can write the formula, that is electric current is equal to electric current is equal to charge, the amount of charge divided by the time. Here current is represented by I and charge is represented by Q and time is represented by T. Here the SI unit of current is ampere and the SI unit of charge is coulomb and the SI unit of time is a second. Therefore we can write 1 ampere is equal to 1 coulomb divided by 1 second. That is 1 ampere is equal to 1 coulomb divided by 1 second. So using this formula we can solve the numericals. Using this formula we can solve the numericals based on this formula. The amount of charge passing through the particular cross sectional area in unit time, that is called as a current, and there are small units to express the current such as milliampere and microampere. 1 milliampere is equal to 1 milliampere, that is equal to 10 to the power minus 3 ampere, and 1 microampere is equal to 10 to the power minus 6 ampere. So these are the small units to measure the current, and a device which is used to measure the current, that is called as ammeter. Ammeter is connected in a series with the circuit. Ammeter has low resistance. Ammeter is a device which is used to measure the current and it is always connected in a series. Now we will see the numerical based on the formula I is equal to Q by T. I is equal to Q by T. So here the numerical is given as a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Time is given and current is given. Therefore we can calculate the charge. Here we should write first given current I is given, that is I is equal to 0.5 ampere, and time, that is the time is equal to 10 minutes, and we should convert this minute into second. Therefore we can multiply that 10 minutes with 60 seconds. So therefore we get time is equal to 600 seconds and Q is equal to question mark. So we have Q is equal to IT. Therefore, substitute the value of I and T, we will get answer, that is 0.5 into 600. So this point get cancelled and this 0 get cancelled, we get 300 coulomb. 300 coulomb. Q is equal to 5 6 30 and this is the 0. Therefore, we get 300 coulomb charge. 300 coulomb charge flows through the circuit in 10 minutes. In this way, we can calculate the numericals using I is equal to Q by T formula. By rearranging this equation, we get Q is equal to IT, and by substituting the value of I and T, we get answer, there is a Q charge, there is a 300 coulomb charge flows through the circuit. So we will see next numerical based on same formula, that is I is equal to Q by T. So second numerical is a charge of 100 coulomb flows through a bulb in 5 minutes. How much current is flowing through the bulb? In this numerical, the charge and time is given, we have to calculate current. So therefore, we should write given. Here given Q is equal to 100 coulomb and T is equal to 5 minutes. We should convert this minute into second. Therefore, we get 5 into 60 seconds, that is equal to 5 6 30. Here 300 seconds. Time is 300 seconds. So what is the current? How much current is flowing through the bulb? We have I is equal to Q by T, Q upon T. The value of Q is 100 divided by time is 300 seconds. So these two 0 get cancelled, we get I is equal to 0.33 ampere. It becomes 0.33 ampere. This is the current. The 0.3 ampere current flowing through the bulb. Now we will see electric potential and potential difference. Electric potential means the level of electric charges at a particular point. There is the electric potential. We can understand this concept with the help of water level. Here in container A and in container B, water is present and the level of water in both the container is same. Therefore, there is no flow of water from A to B or from B to A, because the level of water in both the container is same. But if we make the difference, between the level of these two containers, then water flows from one container to next container, keeping same water content in both container. But we have to apply force to make it flow. In second case, the level of water in a P container is more and the level of water in a Q container is less. Therefore, water flows from P to Q because the level of water is high in P. Therefore, water flows from high level to low level. Similarly, the electric potential, the level of electric charges at a particular point decides the direction of flow of charges, and if there is a difference in the level of electric charges between 2 points, then the electric charges flow from higher level to lower level, lower level, and therefore to make the difference between the level of electric charges we have to apply force, and that force is nothing but electromotive force, means voltage. Or potential difference means the amount of work is done in transferring unit positive charge from one point to another point in electric field. And here potential difference is represented by PD. PD means potential difference, and potential difference is equal to work done divided by the charge transfer. Charge transfer. We can write V is equal to W by Q. W is the work done and Q is the charge transfer from one point to another point, and V is the potential difference. I have told that potential difference means voltage. Potential difference means what? Voltage. That is the difference in electric charges, level of electric charges between 2 points. That is the potential difference. Here W is equal to, we get V into Q, and the SI unit of potential difference is volt, SI unit of work is joule, and the SI unit of charge is coulomb. The SI unit of charge is a coulomb. Therefore we can write volt is equal to joule divided by coulomb, and we can write that is a 1 volt is equal to 1 joule divided by 1 coulomb, and by rearranging this equation we get 1 joule work is done in transferring 1 coulomb charge by applying 1 volt potential difference. This is the arrangement of this equation, that is 1 volt is equal to 1 joule divided by 1 coulomb. 1 joule is equal to 1 coulomb into 1 volt.